Hello. Here is an example of solving a correlation problem. You'll notice there's a few things different from the way we did it in Psych 213, so hopefully you'll have something new here. The hypothesis we're testing is that mindfulness is related to emotional stability. We have it organized into the 5 steps. We're going to check the assumptions to find out whether Pearson or Spearman test is needed, and then we're going to test the hypothesis at 0.05. So population 1 is people like those in our sample. And population 0 is people who have no relationship between X and Y. And you can copy paste these. This is just to remind ourselves what we're doing. Our X variable, in this case, I guess mindfulness is listed first, so we'll list that as X. And emotional stability is our Y. And I don't see any direction predicted, but even if I did, our instruction for this week is that we're just going to use a two-tailed test. Our research hypothesis, you can state it quite simply. We'll just state that R is not equal to 0. I'm going to use this coding way of stating it, NEQ. It's a little hard to get that equal sign with the line through it. And the null hypothesis is that R equals 0. So the first thing we're going to do is create the scatter plot, estimate relationship, identify outliers, and so forth. So in order to create the scatter plot, we have to select the data in both of these columns. I actually can't remember if we can include the headers or not, so for the moment we will. And what I'm going to do is select from the header down to the last person, and then I'm actually going to hold my control key down, and that will allow me to select the second column. And I'm just dragging here. If I want to, I can hold the shift key. That'll take me to the bottom. We're just going to go to insert and let's get the scatter plot. Okay, there it is. I personally think we should change the axes on this. I'm right-clicking on the axis. We need for a scatter plot to really just have, for the scatter plot for a correlation, we really do want to just show the range of the distribution from the minimum to the maximum. Our lowest X value is just above 15, so we'll change that. And I'm going to change the Y-axis as well. I can see our lowest point is, I'll say, just above 25, and that makes it a little nicer to look at. And I'm going to give it a quick title, Graph 1, Scatter Plot, showing relationship between mindfulness and stability. And what we need to do is grab it and drag it up to where we want it. I'm going to just change the shape a little there. That looks a little bit better. And I'm just going to do Control X. I'm going to cut it and paste it up where we need it, which is way up here. So here's our first thing that we needed to do. Here's our scatter plot. I'll shrink it down a little bit. And I think that does look like a relationship. I'd say this is a linear relationship. I could draw a straight line through it. And I honestly don't see any particular outliers. All the points are kind of in the general direction of the data. We do need to draw a line through it as per the instruction. I don't have my pen active right now, so I'm going to do it the way many of you need to do it. And I'm just going to draw the line that from my eye seems to fit the greatest number of points. That's our regression line. And from that, we can tell how strong this relationship is. So I'm going to say no outliers. And my estimate for this, I think it's going to be a moderate relationship somewhere in the range of 0.5. I think that just because of the shape of the points here, and remember, the direction doesn't matter. The direction will change as we change the dimensions, but let me make that clear. This is a positive correlation, but the angle of this line doesn't really matter because the angle will change as we, just adjust these kinds of things. Then we have to move this line. So the angle of that line doesn't matter. That really is just contingent on how the orientation of the points are. So let's go on. In step 2B, we're checking the assumptions. So the assumptions, we're meeting all of them, having continuous data and so forth, but we do have to demonstrate normality. So I'm going to grab both of our columns of data. I wonder if I can copy them both at once for here. Let me see if I can do that. Just grabbing up both of these columns. And I think I will get headers this time. We're going to put them into the QQ plot creator. And I think we won't even bother. I don't think it'll let me. Let's see. No, I can only copy one at a time. So let's first check normality in the mindfulness variable. So I'm going to the QQ plot generator and I'm going to just do a reset. Yes, we can reset that. And now I'm going to click on the sample data. Oops, I'm going to click on paste upload data. And let's delete all of that out of there. Paste our new data in. In this case, I did bring the header in. So let's import the data. We go down to select columns and options. I'll select mindfulness and generate the plot. And we can see here, I think it's probably going to be a play. It looks like it has a little bit of kurtosis, like this really tiny bit of an S shape. But I think we're okay, and we are okay. Our p-value is fine. I'm going to just zoom in on that a little. I'm going to get a teeny little screenshot here, and then I'll zoom back out again, just to show you how this needs to be set up here. And my snipping tool is right here. Let me get a new, and I'll just put this right into our spreadsheet. It does say that our Pearson statistic is non-significant and the data appears to be normally distributed. So let's put that for our first variable into the spreadsheet. Going back up to here. And it is pretty big, kind of cumbersome there in terms of our use of our spreadsheet, but that's okay. We'll make it work. We'll comment on it later. They can kind of make it small a little bit. Let's get our other variable then, the emotional stability, and go through that process one more time. And put it into our generator. Zoom in a little bit here so you can see what I'm doing again. And I know you already know the process. Let's just take a quick peek here, select the column. And once again, that may be teeny bit of kurtosis, but probably nothing to worry and nothing to worry about. Our test statistic is close to 1, which is what we needed, and the p-value is 0.41, meaning it's not significant. That just means our data set is not significantly different from what we would expect if this was a normal distribution. So here I'm grabbing this, I'm going to put it in the spreadsheet. And with just that work already, we can assume that our data are normally distributed. And I'm going to say yes to using this. Oops, I'm going to undo that and put it back where I need it here. And I'm going to say that, yes, this is adequate. Our Shapiro-Wilk says it's normally distributed, so we're going to be able to use these data with the Pearson test. If we had one of these variables that were not normal, we would have to use Spearman's rho, which is the rank order that I'll show you in the next lecture. So yes, I'm going to say yes, and it says explain, so I think I'll just comment on the both QQ plots. Show a little kurtosis, but the Shapiro-Wilk was non-significant. And that's good enough. So we need the Pearson R because it is normally distributed. Next, we go ahead and look up alpha, the R score associated with alpha. And the way to figure degrees of freedom is the number of pairs minus 2. Going down to the data, I can see that if these are properly numbered, we do have 34. I'll just do a quick check and make sure we have 34. And indeed, I'm pretty sure we do. And it does say 34. So we can go ahead and enter that into our critical value calculator. So we're looking for an R value at 0.05, and we have 32. Number of pairs minus 2 for our degrees of freedom. We're using always two-tailed here. And we get the 0.3388 for our cutoff point. So we can put that in right here. I'm not asking you to draw the diagrams anymore. I think that part of what we're doing is clear to most of you. So we know that we're just looking for an R score in our sample that's more extreme. In this case, we know now we're going to be doing the Pearson test. We don't have to do anything more. And I'm going to stop the video here and then make a second stage video to go on to the calculations.